Hey guys, welcome to section 3, chapter 4 of the Pre-Algebra program. And this is a particularly fun section, I think, because we get to do something called prime factorization. And hopefully you have seen or maybe worked with this a little bit in the past. As I just learned, it has been a fifth grade standard for a while. I did it with a fifth grader a couple of weeks ago, but if it is your first time, hopefully you'll catch on pretty quickly. It's not too challenging, and it's kind of a little bit fun, if I dare say. So in this section, we're going to review the difference between prime and composite numbers. We are going to learn factorization, prime factorization, and then of course we're going to be writing numbers as the product of primes, which is the objective for us in this section. So just to review, a prime number is only divisible by itself and 1, versus a composite number, which has more than 2 factors. So let me just give you a quick example here. If I had the number 17, 17 only has 2 factors, itself and 17. Nothing else goes into it. Therefore, it's prime. Unlike 36. 36 we can make up in several ways, like 6 and 6, 12 and 3, 9 and 4. It has lots of factors, and that makes this number composite. All right, again, that should be pretty old school, so we're not going to spend much time with that. We're going to jump right into writing prime factorizations. All right, so let's take a number like 72. All you need to do is come up with 2 factors that multiply to 72. Any 2 factors work. I'm not looking for a specific set. If you can just get 2 numbers that multiply to 72, then we'll be on our way. And if you don't see it right away, but notice that our number is even, you know that 2 has got to be a factor of 72, for example. And then hopefully with a little bit of quick counting, you could come up with 36 as the other number. So 2 is always a safe bet when you have an even number. Okay, now the idea here is that we're going to break down these factor trees until we get all primes. Now 2 is a weird number because 2, although it's even, it's also prime. So 2 can't break down to anything else except 2 and 1. So therefore, we're going to leave 2 just where he's at. But 36 can, of course, break down again to 6 times 6. And even my 6's can break down to 3 and 2 and 3 and 2. Okay, now once I get down to 2 and 3 and like 5 and 7, those are prime numbers. So once we get down to all primes, then our factor tree is done. And I'm going to identify how many factors of each I have, of each of the primes. So in this case, I count 1, 2, 3 2's. And in the last section, we learned how to write with exponents when we have the same term with repeated multiplication. So in this case, I have 3 2's, so I'm going to write 2 to the 3. And then I have another number that's prime, and in fact I have 2 of them. Don't know what happened there. I have 3's, and in fact I have 2 3's. So the prime factorization of 72 is 2 to the 3 times 3 to the 2. And again, utilizing a skill that we learned last section, we could actually expand this answer to double check. So 2 to the 3 means I have 2 times 2 times 2, which is 8. And 3 squared means I have 3 times 3, which is 9. And when I multiply 8 times 9, I get 72. So again, a fun thing in math where we can do a lot of work and then come back and check our answer. Okay, let's work on another example. What if I had, what if I had something like 35? Well, the first two numbers that jump to me would be 5 and 7. But 5 and 7 are both prime, which means I can't go any farther, meaning I'm ready to write my prime factorization. So my first prime, or my lowest prime, is 5, and I have one of those. And my next prime is 7, and I have one of those. So 5 to the 1 times 7 to the 1 is the prime factorization of 35. Okay, I'm going to do one more for you. Let's do something big like 156. Again, if you're not sure but recognize that it's even, let's go ahead and do some quick math and see 2 times what equals 56, and hopefully you'll come up with 78. And 2, I got down to 2 here, so I know that that guy is prime, but 78 certainly can be broken down again to 39 times 2. Here I got 2 again, so he's good. Let's keep breaking down 39. 39 is 3 times 13. And both of these numbers are prime, so I'm done. Now I'm going to count the number of primes I have and write my prime factorization. So I have 2 2's, so I'm going to have 2 to the 2. I have 1 3, and then I have 1 13. So the prime factorization of 156 is 2 to the 2 times 3 to the 1 times 13 to the 1. And that's it, guys. That's the whole section. That's the main idea here I want you to extract. So your assignment is pretty short. You're welcome. So at this point, I want you to finish up your notes. Make sure you read through the examples and the section in the book and begin your assignment.